Hey, good morning. My name's Andrew Carnahan. My paper was on epoxy-based reactive polymers. The title of it is called Reinforcement of Stereolithographic Resins for Rapid Prototyping with Cellulose Nanocrystals. Cellulose nanocrystals are a nanofiller that they get from a chemical reaction. The scope was to explore how introduction of these small amounts of these crystals into the resin would change the viscoelastic and the mechanical properties of the composite, and then also compare that to other nanofillers like carbon nanotubes or cellulose nanotubes or fibers. So this is how they got the crystals. They made 3 batches and they isolated it from cotton using acid hydrolysis. And then they mixed it with the resin at 5 different percent weights. So 0.5, 1, 2, 5, and 10%. And this is an example of the monomer structure. The acrylic is in green and the epoxide is in red, and then these little black things are the nanocrystal. So they didn't explain how they tested any of the viscoelastic properties, so they just kind of gave results. So this is the graph of the viscosity versus the shear rate with respect to the percent crystal by weight. And you can see that at 0.5 and 1%, didn't really have much effect on the viscosity of the resin, but at 5 and 10% it had a bit more. And up to 0.9 Pascal seconds is still kind of typical for nanofillers. So, oh, and also as a side note, they did like some powerful imaging, and they found that at 5% aggregates of the crystals started to form in the resin, which is a little more significant to the mechanical properties, like the tensile strength and stuff. I'll tell more about that later. Okay, this is the one of the other viscoelastic properties, storage modulus, which I wasn't really familiar with, but in layman's terms, all I could find was that it depicts like how much energy the resin stores. And as you can see, with the increase in the weight percentage of crystals, it greatly increases the storage modulus from at a max of 0.33 to 0.23. So that's like right there in the rubbery regime. So this is the mechanical effects. They tensile tested the specimens using the ASTM D638, and as you can see, with each weight percentage of crystals, the Young's modulus keeps increasing, so the slope keeps increasing. Although at 5%, which are these triangles, the ultimate tensile strength of the material actually decreases, and they theorized that the formation of the aggregates that I talked about is what caused that, because it could have given stress concentrations. Okay, and then they also did bending tests, and the results were similar to the tensile testing, which is flexural, or the bending modulus, is what you want to look at here. So it continues to increase, and then it kind of drops off at 5%, although at 5% it's still above the original neat resin. But again, the 2% is kind of the lucky number, per se. And then so the last thing they talked about was how the nanocrystals compare to other nanofillers, so like the carbon nanofibers or nanotubes, graphene, and then even other cellulose nanocrystals derived from other organic materials, like besides cotton. And then they just kind of made the statement that since the properties, the increase in properties are comparable to other fillers, that the CNCs from cotton are more attractive due to their lower cost and their renewable nature. And so personal critique, I thought the paper or the results were pretty clear and concise, but I would have liked to see more focus on how the fillers compared to other fillers, like specifically with respect to the properties, and then also how they tested all the viscoelastic properties.